Hello everyone and thank you for joining this presentation. My name is Mohammad Ali. Today I will be presenting our research titled GIS-based multi-criteria decision analysis for retention bond site selection in flood-prone areas of Amman, Jordan. This study addresses one of the most pressing challenges in the region, urban flooding, and demonstrates how GIS and MCDA techniques can support effective flood mitigation planning. Background and the problem statement. Urban flooding has become a recurring challenge in Amman-Jordan due to a combination of factors: rapid urbanization, steep mountain terrain, limited drainage infrastructure, increase in previous services, intense short-duration rainfall events. These conditions result in excessive surface runoff, overwhelming existing drainage systems, especially in downtown Amman. Retention ponds are widely recognized as effective and cost-efficient flood mitigation structures. However, determining the optimal locations for these ponds requires the integration of hydrological, geological, land use, and infrastructure variables. This is where GIS and multi-criteria decision analysis (MCDA) become essential. About research gap. Although flood hazard mapping has been widely studied in Jordan, most existing research remains descriptive and does not translate flood risk into practical mitigation planning. Current studies rarely identify optimal locations for retention bonds, seldom apply structure weighting methods such as AHP, and provide limited GIS-based decision support for real-world implementation. This study fills this gap by developing an integrated GIS MCDA framework that supports actionable, special explicit flood mitigation planning for Amman. The main objectives of this research are to develop an integrated GIS-based multi-criteria decision analysis (MCDA) framework utilizing the analytical hierarchy process AHP for the systematical elevation and weighting of flood-related hydrological and land use criteria, to produce a special suitability map identifying optimal locations for retention pond construction in flood-prone areas of Amman, Jordan, to validate the reliability and predictive performance of the proposed model of comparing high suitability zone with historical flood records and document flood-prone location. The study area covers major parts of Amman, characterized by complex mountains terrain, valleys draining towards the city center, highly variable slopes, urban expansion, and land use changes. The features make Amman an ideal case study for GIS-based flood mitigation planning. For data and criteria, there is 9 parameters were selected based on literature, expert input and local hydrological, elevation control lines, soil properties, drainage network, street network, land use, rainfall intensity, slope, stream order, watershed boundaries. Each criterion plays a distant role in influence flood behavior. For example, slope, gentle slope, less 5%, reduce runoff velocity and support infiltration. Elevation, low-lying zones are potential catchment area. Soil, high probability, soils enhance infiltration. The AHP weighting. The analytic hierarchy process was used to calculate the relative importance of each criterion. The highest weight were assigned to elevation, soil properties, slope, watershed boundaries. These were followed by land use, stream order, drainage network, and street network, rainfall intensity. A ratio of CR 0.005 confirms extremely reliable expert judgment. GIS processing and suitability analysis. Following data preparation, each special dataset was processed within a GIS environment through a structured multi-step approach. First, all criteria layers were reclassified into standardized suitability classes based on threshold derived from the literature, expert knowledge, and local hydrological guidelines. Second, AHP derived weight were applied to each criterion to reflect their relative importance in influencing flood behavior and retention pond visibility. Finally, a weighted overlay analysis was performed to integrate all reclassified and weighted layers, resulting in a comprehensive retention pond suitability map that specially represent optimal, moderate, and unsuitable location for floodwater retention. The AHP results show that elevation and soil properties are the most influential factors in selecting suitable retention pond locations. Slope and watershed boundaries also play a major role as the control runoff direction and flow of communication. Land use and stream order have moderate importance, where rainfall intensity and infrastructure-related factors show lower influence. These findings indicate that flood behavior in Amman and primarily controlled by terrain and land use rather than rainfall intensity alone. In this slide we have two tables, the random index and white sum value. To determine if assessments are consistent, the final CR is determined by dividing CI by the random index Ri. If CR equal 0, so that's mean would show that all respondents 100% reported accuracy in their judgment, and in practice CR is acceptable at 0.1 or less. The model was validated by comparing the high and very high suitability zones with historical flood records, known flood-prone locations in Amman, field verification, high-resolution satellite image. The results showed a strong spatial agreement, confirming the model's accuracy and reliability. The final suitability map classifies the study area into 5 categories: highly suitable, suitable, moderately suitable, less suitable, unsuitable. The most suitable areas are in the mountain zones draining into downtown Amman, which historically experience recurring flooding, as shown as the retention pond suitability map. The findings underscore the importance of integrating multiple environmental factors in retention pond planning. Slope and elevation emerged as the maintained factors aligning with hydrological principles that slopes and low-lying areas facilities venting and infiltration. The low weight for rainfall intensity reflects its indirect influence compared to topographic and cover variables. Model validation demonstrated strong spatial agreement between predicted suitable sites and historical flood records, confirming the utility of the GIS-MCD approach compared to earlier Jordanian flood studies, which primarily focused in hazard mapping. This research extends to actionable flood mitigation planning by identifying feasible sites for pond construction. In a conclusion, we developed a GIS framework to identify optimal retention pond locations in Amman. The model identified 48 km² for suitable areas. Results offer Urban Planner a decision support tool for flood mitigation. The approach improves resilience planning and supports suitable urban development. Future work should include climate change projection analysis and hydrodynamic modeling to refine pond sizing and long-term performance. Finally, thank you for your attention. I will be happy to answer any questions.